And we are live. Hi everyone, my name is Kent Quirk. I am a programmer. I work for Honeycomb, who is sponsoring me for Advent of Code, along with a bunch of other people. We're going to be solving Advent of Code Day 5 today. Generally, I solve it in Go. I generally solve it using what tries to be defensible engineering practices. Hopefully I can teach a little bit about Go and about computer science as we go. So without further ado, let's just switch to it and see what the problem is for today. I haven't looked yet. We're going to discover it together. So I'll switch over to my browser. And here we are, day 5. We've come across a field of hydrothermal vents. They form in lines. Lines go from point to point. We're parsing points. For now, we're only considering horizontal and vertical lines. We have these 1, 2. Why are we having 1s and 2s? Oh, number of points, number of lines which cover that point. Okay. All right, so we are drawing lines on a grid, horizontal and vertical lines, and so we need to find points of overlap. Enter your coordinates. Now, as described, the easiest way would be to simply create a grid and fill them in, and every time, color in lines on the grid, and every time we hit a point, we just increment its coordinate count. So we create an empty grid. Then we just have to find all the ones whose value is greater than 1. And it doesn't seem like it's going to be a lot harder than that. The main question is going to be, I think the grid is going to be sort of arbitrary in size. So we either need a model where we can grow the grid, like it might actually, so I'm going to start off by copying this data into my editor. So I'm going to switch over the editor and copy the input data to the editor. This is the sample data. And I'm also going to get the puzzle input and copy it to the input.txt. So there are 500 items in that, and they cover a pretty broad array. It looks like up to 3 digits. However, I don't see any negative numbers, so it is positive. Now, one thing we could do here would be to look at this as a so instead of creating one big grid that was big enough to hold everything, we could treat it as sparse data. So we could store it all on a map where the map key is the coordinate of the point. And then we just fetch items out of the map. And that's a useful way to go, depending on the density of how much we're coloring these things in. Kind of inclined to try that. The only danger is the second half of this puzzle. If they're asking us to plot a straight line route or something that it doesn't touch, yeah, it's still probably reasonable to do it with a map. So my inclination is to store the data in a map. First thing we have to do is parse the input data. So if we look at the sample data, it's number, comma, number, arrow, number, comma, number. So I'm going to parse this with a regular expression because that's pretty easy to do here. So let's do a func parse line. Takes a string and returns 2 points. So actually, we're going to need a point data type as well. So let's just create one right now. Type point struct. I mean, we could just do this as a, yeah. I like to do it. I think we're just going to do it that way. So, oops, I'm going to make those X and Y. Okay, so we're going to parse a line and we're going to say pattern is regex dot must compile, and the pattern we want is 0 through 9 plus comma 0 through 9 plus, no spaces in there, arrow, and then same thing again. Now, actually, the way it'll make that even more useful will be to turn it into groups of the numbers. And so now we can use the groups feature of the pattern. So we can do data equals at dot find all submatch, all string submatch from S. And so that is going to return to us an array of string. Wait, no, not find all string submatch. Find string submatch, which will return a slice of string. And so since we have 4 subelements, we know we're going to have 4 values in the find string submatch. We're going to actually have 5 because the 0 value is always the full match, and then 1, 2, 3, 4 are the 4 submatches. So what we're going to do is we can say So I'm writing a little A to I helper function that ignores the error, so that it's easier to write the expression that I want to return. And so I'm going to just do n underscore equals colon equals strconv dot A to I s turn in. So, whoa. The reason for doing this is so that I can say return slice of point and x is A to I of data of 1. Y is A to I of data 2, curly brace, comma, and there. Okay, so so that is now going to return a slice of points. So I'm going to return an array of 2 points instead. And now we just need to be able to, so we need to be able to draw a line, and I'm kind of tempted, actually, in this instance, to do a type line, which is a struct, and it's just p1 point p2 point. I don't think I think it's going to be easier if I just write a helper function that deals with this, and it'll be a little easier to cope with. So that means that this line all right. So now we're going to return a line, and now we're going to give line a couple of helper functions, or at least one. Type. It's going to be simplify the logic. So what we're going to have to do here is we have to decide whether it's vertical or it's a horizontal line, and then we want it, just to make our loop easier, we'd like to have that line be ordered so that the lesser point the one, so we can do a positive increment to get from one to the next. So we're going to have a actually let's do this. New line takes P1 point, P2 point. And we are going to return generally, if something has the name new, you should use it as a pointer. It's just a good practice to follow. So we are going to we're going to write a less function type or func p point less other point if, and it returns a bool. So if p dot x is less than other dot x, or p dot y is less than other dot y, turn true. And false. All right. If p1 dot plus p2 return line for p1 1 p2 2, otherwise return line of P1 2 P2 1 wait. I wasn't thinking here. Return a pointer to that. And that's a colon. All right, so there's a new line. So this now returns a pointer to a line, and this returns new line. Okay, so, all right, now we've parsed the line and it's in the appropriate order. So now we can have a draw function on line. So we need a type, not a type, func L star line. Well, actually, we'll just do a line in case, because it's going to be a draw, and it's going to take the data or map. No, map is the name. Grid, which is going to be a map of point to int. So it is going to so let's just have a helper function here. If L.P1.x y so if both y's have the same value, we're going to return it. And that will be, so if the y's have the same value, it's horizontal. If not, then it's not horizontal. So we can say if L dot is horizontal, x equals range. Let's do it this way. X is P, if it's horizontal, X is P1 dot is L dot P1 dot X. X is less than L dot P1 Y, no, less than or equal to, because we're going to go up to and including the last point on the line. X plus plus. And then we're just going to say that grid point x colon x y colon L dot P1 dot y plus plus. Because that grid is going to return the 0 value of int if that element is not in the grid. So the grid is essentially an empty grid, and then we're going to increment it as we walk along the line. And then if it's not horizontal, this is a case often in Go, if you're you tend to try to push things as far to the left as you can. So often in Go, you could just right here return immediately inside that thing, and then otherwise just leave the Y climb, the Y iteration to the outside edge. But in this case, I think it's clearer to just do else, because there's only two cases, horizontal and vertical. So instead, we're going to do Y is all of P1 dot. Oops, Y. Okay, I did that wrong up here. P2 dot x, and y is P1 dot y, or P2 dot y, because they're the same, because they're horizontal. Now, in this case, we're going to do p1.y, we're going to do p2.y, and y++, and then we make a grid point of l.p1.x, and then y is just the value y, and we increment that. So that draws that line. And then we can iterate our grid to find the answer. So let's write day04.05.a. Okay, so we are given a slice of strings, and it's going to return an integer. So count is 0 for Lagrange lines. So for each line, we're going to I'm going to call this input. L is parse line of imp. L dot draw. Oh, we need to create our map, our grid. Grid make map of string int. Sorry, point int. And draw. I'm just going to move this down here because I don't need it till later. So draw into grid. And then for KV in actually for underscore V, I don't care what the keys are, I only care what the values are. For right now, we'll just do the values, range grid, if V is greater than 1, count ++, and then return count. Okay, so that's day 5A. All right, so we're going to do it with input sample, and with the input sample, we should get an answer of 5 if we did this right. There are no obvious syntax errors, so I'm going to open a terminal. Go run main.go. 4. Well, that's too bad, because now we got to debug it. Shoot. What did we do wrong? Our input data, input sample, 09 to 59, 80 to 008. That doesn't make any sense. What's going on here? Oh, only consider. horizontal and vertical lines, so I ignore lines that are not horizontal. Oh, I completely missed that part. So just to show you, the part I was not paying attention to was that we're only considering horizontal and vertical lines, and that some of these lines are not horizontal or vertical. So I need to fix my tests a little bit and include only certain lines, because I don't know what I drew, but it was wrong. Okay. So we're going to give it this vertical function 2, and otherwise we do nothing. So that will do us for now. Is vertical, says the P1x and P2x are the same. Now, if I were to do that, it's even worse. Oh, what is draw doing? Oh no, draw's incorrect. So, just for fun, I'm going to print the grid after drawing all the lines. And, whoops, I apologize, did it again. Here's my editor. I just made it so that draw has an is vertical function method test as well as a horizontal test. I added this is vertical function, and now the answer I got was 1, which is wrong. So I'm going to print the grid and see what I've done. It seems implausible. This grid should match effectively the grid that's here, although I didn't go to the trouble of printing it out. If it gets worse, we could do that too. But let's try it this way first. So it claims that I have a bunch of stuff at 0, 0, 0, 1, 0, 2. So x is 0, a whole bunch of stuff down the left column. So what I'm going to do is new line. I'm going to print that as well. See what my lines are that I got. 0 to 9, 9 to 5, input sample. 0, 9, 9, 5. What did I do? I swapped the inputs. Parse line. I did. I did 3 and 4. Now, just for fun, a whole bunch of all right, this should be a lot better. Let's try this again. Okay, I got 5. I can suppress my print statements. That's better. Yeah, all right. I buy that a lot more plausibly. So we're going to take into the input.text. Oh. $5,197 overlapping points. That's a lot. But let's see if it's correct. 5197. Okay, wait. First, I'm going to show you my browser. That is the right answer. Yay. Okay. Let's continue to part 2. We need to consider diagonal lines. Of course we need to consider diagonal lines. Oh, and fortunately, we don't have to worry about... Okay, so we can draw diagonal lines. We just have to increment both x and y. That's easy enough. Because of the way I structured it, it should be just fine. Now, in normal line drawing, you know, what you do is you start drawing a line and you go like, you know, if you're drawing 45 degree on a grid, that's fine. You just increment both the whole time and everybody's fine. But if you're doing like a slope of 2 or a slope of 1/2, then what ends up happening is you have to go like down 2 and then over 1 and then down 2 and then over 1 and then down 2 and then over 1. And the problem is, how do you deal with the fact that you're basically accumulating an error and incrementing along? So you could, if you started with an error, you know, you could have valid lines where one started off with 1 down and then 1 over, and then 2 down and then 1 over, and two down and 1 over, and da, 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 da. So they're almost the same line, but they're off by 1 pixel. These guys probably didn't want to deal with that, so let's just do diagonal lines, perfectly diagonal lines, which is great. And lines in your list will only ever be horizontal, vertical, or diagonal line at exactly 45 degrees. So all we have to do, so there's 2 things that we're going to have to worry about. One is the sorting of our points might need to get more sophisticated. I have to think about that for a second. And then the other thing is the, you have to draw the lines. So, so what I'm going to do is I'm going to rename this function to draw HV. Because it only draws horizontal and vertical lines, and then that way we can keep day 5a because it's calling draw HV. And I don't think we're going to have to worry about anything else, but now I'm going to duplicate the draw HV function and do a draw diagonal, you know, just a generalized draw. And I think what we'll do is we'll do an is diagonal function. Whoops, I'm sorry. Switch back to my editor so you can see that. And we are going to it's diagonal if dot p1 dot x is not equal to L dot p2 dot x and L dot p1 dot y is not equal to L dot p2 dot y. If both of those things are true, then it is a diagonal line. And the ordering so we want the ordering to be, we always want x to be in the right order. So we're going to change this to two if statements. So if p dot x is less than other than x, then it is correct. If p dot y is less than other dot y, so p dot x is not less than other dot x, then it might be equal. So and okay, so if p dot x is less than other dot x, we know we're in the right order, regardless of whether it's diagonal or not. If p dot y, if p dot x is equal to other dot x, then we need to test if p dot y is in the right order. And if it is, then it's true. And if it isn't, then it's false. Otherwise, p dot x is just out of order and we have to fix it. And this has to become a capital letter X. There we go. All right, so less is going to return the right ordering for diagonals now, so that we can just iterate. So if it's horizontal, we do that. If it's vertical, we do that. Else, and you know what? I'm going to do this as a switch because I like the switch structure of the switch a little better. Switch, and we're not going to put a thing to switch on here. We're just going to do a series of cases. So case is horizontal. Case is vertical. Case diagonal. And for diagonal, we can still iterate in X order. But the Y value also needs to iterate. We just don't know in which direction yet. If y is less than L dot p2 dot y, y plus plus, else y minus minus. So that should draw diagonal lines. And day 5B is just going to do the same thing as day 5A, but it's going to call it's going to call draw without the HV. And so 5A and then let's just run this on input sample 512. Good. And so therefore, if I run it against input.text, $18,605. And that is the right answer. We did it. Yay. Okay. So yeah, we have solved day 5. We're busy drawing a submarine, maybe with a sleigh attached to it. It'll be interesting to see how this goes. But yeah, we are done. So thank you all for tuning in, and hope you have a great day, great rest of what left of your weekend. And I'll be back tomorrow to solve day 6. Hope you have a good one. Bye.